For E, the domain of validity would be the following. X is greater than 3 and x is greater than 5. Therefore, x has to be greater than 5. That is, belong to 5 excluded and positive infinity. If you want, you can eventually use a number line. I don't need to see it. I don't mind seeing it either. So I've got 3 and 5. So greater than 3, and so I'm going to use another line, greater than 5. So it's the interval common to all lines that will be the final domain of validity. Anyway, let's go back here. So I've got ln of 3. I'm going to same thing. I cannot just cancel ln, right? ln, like the natural logarithm, is not a coefficient, so a multiplier, a factor. It is an operation. So I cannot divide by ln. It doesn't make sense. But I'm going to condense this addition and have x minus 3 times x minus 5. The multiplication becomes, the addition becomes a multiplication inside. And now both logarithms, because they encompass, they wrap up the entirety of both sides, are going to cancel out. So I'm going to have just 3 on this side, and here I'm already going to FOIL that expression. X squared minus 3 minus 5 is negative 8, so I'll have negative 8x and plus 15. And then I'm going to deal with a quadratic expression that I know how to solve, and 15 minus 3 is 12. And same thing, if you need, you can do that on scratch paper. You can do that in several steps. You can use the diamond method that I taught you. I don't need to see it. When it's that simple, I'm completely okay with you giving me directly the result. And the two numbers I'm looking for are those two, which is that x equals 2 or x equals 6. But in that particular case, this is why it is important every single time to perform the domain of validity, to determine this domain of validity, is that 2 is here and 6 is there. Only 6 belongs to the domain of validity, which means that x equals 2 is in fact an extraneous solution. Because of that, you need to conclude that x equals 6 and 6 only. You do not need to specify that x equals 2 is extraneous. It's self-explanatory.